so I'm gonna get on here. I'm gonna do some calculus. I want to take a look right quick. Well, let me see if I can get this to um, what I project. It's like eventually we'll start. Well, we've already started with uh, development of vectors and so on, and um, um, we're going to develop vector calculus. And this is thought I had. It's like if you had differential and integral calculus, right? Really, vector calculus is a great place to like review everything, right? It's like I thought myself, it's like I haven't done like really hard trigonometric or trigonometric inverse integrals and stuff like that. Oh, wait a second. I got audio going. Okay. I'm just gonna check my mic and make sure that I'm on the right device here. Um, the next I go. Okay. So I'm hoping that's gonna be good quality. But uh, then we'll go on. We'll get into partial derivatives, and I'll tell you the truth, man. You know, I had an Austrian advanced calculus teacher and a Chinese advanced calculus teacher, and they would just shake their heads at American, students. They're like, "Man, you guys are like really, really behind." And I guess we are in the state of Georgia, so we're pretty even further behind or whatever. Um, but they'd be like, "You guys are not going to be able to solve unsolved problems. You can barely solve problems that everybody knows already in the world knows how to solve for several centuries." Um, so yeah, we'll hopefully keep it going. What I'd like to do is on this program is to just go all the way on up through this calculus uh, uh, vector calculus, maybe even to the end of the book. And where I was, let me see. Well, it's gonna load. Um, yeah, we'll get up here into the wild stuff, advanced stuff, and yeah, this book that we're on, you can see it's on archive. You just create an ID and log into it. And so, starting out, um, well, let's just start doing problems. That's what I'm going to do. All right. In exercises 1 to 4, plot points A and B on a right hand coordinate system. Then calculate the length of the line segment AB and find the midpoint. So I've got 2, 0, 0, 0, 0 minus 4. 0, 0 minus 4. Now, how am I gonna do that? Well, okay. Well, okay. Um, let me show you how I'm inclined to do it. So, uh, that we say that in our the way we develop this, we call these A B C, right? So, or no, X1 X2 X1 y1, z1, and x2, y2, z2. All right, so we're going to get d a b, right? And that's going to be equal to the square root of x2 minus x1, 0 minus 2 squared, plus, oh, is it asking me? Just stay in the call. I want to check and see if my audio is coming across. Audio settings. Yeah. Mexico. Good. All right, should be working. I started to work out this problem and I forgot that I had my dang thing set up different. Okay, so let me go back to the beginning here. I need to turn off archive. All right, so what I said, I've got a point A, 2, 0, 0, and a point B, 0, 0, negative 4. And I labeled the points x, x1, y1, z1, x2, y2, z2. And I go 0 minus 2 squared plus 0 minus 0 squared plus negative 4 minus 0 squared. Right, that's all I got to do. Okay, 16. So it's going to be root 20. Right? All right, now that's going to be 2 root 5. What is that number? 2 times the square root of 5. And you know, I'm the kind of person when I see the square root of 5, right? I like to think about what is the size of that number. Now, the square root of 5 is less than the square root of 9. Right, that's the next perfect square, but it's greater than the square root of 4. Right, so that's gonna imply that 2 is less than the square root of 5 is less than 3. So it's between 2 and 3, which is that's kind of nifty, you know, to get pretty close to where it is. So that also is going to imply, if I multiply through by 2, that's going to give me 4 is less than 2 root 5 is less than 6. So it's between 4 and 6. That's about the size of it, you know. And whatever the unit is, you know, parsecs, or yeah, you know, inches or you know, metric, whatever it is. So what is that? That's the distance between A and B, and find the midpoint. All right, now just as I'm gonna illustrate this again. I like to sort of reinforce things. So if I have 1, 2, 3, 4, 5 on the x-axis, and I want to get the midpoint between 1 and 5, I just take 1 plus 5 divided by 2, which would be 6 divided by 2, which is equal to 3. Now, you can see, yeah, in fact, that's equal. So generally in 3D space, we're going to get 2 plus 0 over 2, comma, 0 plus 0 over 2. I'm being silly. And 0 plus negative 4 over 2. And that's going to be my midpoint. So that's going to give me 1, comma, 0, comma, negative 1. The midpoint. Got it? Oh. Negative 4 divided by 2 is negative 2. That's what I think. All right. Now, what next? I have another point, 2. I'm going to circle this. And what is that? A negative 2, 0. A is A negative 2, 0. 0, comma, negative 2, comma, 0. And comma, B, 0, 0, 6. All right. Now, again, we have x1, y1, z1, x2, y2, z2, just to help you remember. So we have d, a, comma, b is equal to the square root, and this is 0 minus 0 squared, 0. 0 minus negative 2 squared is 4. And 6 minus 0 squared. Wait, what's it? 36. It's going to be root 40 is equal to 2 root 10. I think that's right. Well, we used to do it this way. I've got 2 times 2 times 2 times 5, right? I can't do anything with this, right? That stays inside. And this comes out as 1, 2. So it's 2 root 10, right? All right, now in terms of the midpoint, 0 plus 0, 0. Oh, divided by 2, right? 0 plus, let's just write that. 0 plus 0 divided by 2, comma, 0 plus negative 2 divided by 2, comma, and 0 plus 6 divided by 2. All right. So 0 plus 0 divided by 2 is 0. And negative 2 divided by 2 is negative 1. And 6 divided by 2 is 3. With me? There's watercolor on here from my daughter's painting yesterday. Okay, so what is that? That's number 2. Let's go with 3. And that's going to be a 0, -2 function. Right, comma b 4, 1, 0. So d a, the distance from a to b is equal to the square root of 4 minus 0 squared plus 1 minus -2 squared plus 0 minus 5 squared. All right, so that's going to be 16 plus 9 plus 25. 25 and 25 is 50. Root 50, which is 5 root 2. And just for grounds, 50 is 2 times 25. Which is, 5 root 2. That's how I got that, 5 times 5. All right, let's see. Midpoint out of 9. And these are, I recommend doing all of these, man. I recommend making up some on your own. Because in reality, I used to do this in like parabolas that you're trying to find the intersection of the complex number that's the intersection of a parabola with the x-axis when it's in the complex plane or whatever like that. And when you make those up, man, you get some, sometimes really complicated little numbers there. And I had students all the time going, math is not like that. Because I've been using these math books that are, contrived where everything comes out like really simple and everything all the time. And in reality, you get, complicated stuff. All right. So let me see here. What am I supposed to do now? I'm supposed to go 0 plus 4 over 2 comma -2 plus 1 over 2 comma 5 plus 0 over 2 and that's going to be equal to 4 divided by 2 is 2. -1 divide like -2 plus 1 is going to be -1/2. And 5 plus 0 over 2 is going to be 5/2. And 4/2 is 2. So 5/2 is like 2.5. All right. But think about the one way you can do it kind of handily is you can think about it as the decimal result. You know, if I had a $5 bill, I'm spending it on $2.50. Everybody knows that. I think. Well, I hope people don't use money anymore. This is the thing I was noticing is uh, yeah, man, people don't even you know, it's like they have in IXL, it's a learning management system that we use a lot in the schools or whatever. I'm retiring, man. I'm not going back. If I, you know, I'll go and teach for free. Yeah. Um, all right. What was that? That was number 3. Okay, so we got some space here on the paper. Let's go to number 4. And what have we got? A 430. B negative 206. All right. I'm gonna, if in case somebody is, I'm gonna just let you work it out there for a second, and then I'm gonna do it. Got it all done yet? Let's see how long it takes me to do. Oh, okay. So I've got negative 2 minus negative 4 squared, or I should write, you know, d a b equals the root of negative 2 plus 4 squared. 0 minus 3 squared plus 6 minus 0 squared. All right, this is gonna be 4. 9, 36. Four. 9. 36. 45. 49 equals root. Yeah, I believe that's root 49. Is it? Did I make a mistake? All right. Nice. See, if that is the right answer, that's one of those things that. Thir- um, 36 and 4, 49. Oh no, I think this is wrong. Negative 2 plus 4 is positive. Yeah. Negative 2 minus 4. Oh, this is negative 6. It should have been -2 minus 4. So, 36 plus 9 plus 36. Still designed to come out. All right. Beware arithmetic mistakes. Okay, so 4 minus 2 over 2, comma, 0 minus 3 over 2, 0 minus, oh, 0 plus 3 over 2, excuse me. I'm doing, yeah, I'm confusing the two things. So, 4 plus -2. Okay, 0 plus 3 over 2. And 0 plus 6 over 2. It's going to be 2 over 2, comma, 3 over 2, comma, 6 over 2 is equal to 1, comma, 3 house, comma, 3. All right, am I even on my paper anymore? Let me see. Yeah, good. I'm doing all right. All right. All right. So, in the next exercises, and at 5 through 10, my daughter's playing Roblox. In exercises 5 through 10, find an equation. Find an equation for the plane through. For the plane. The plane. It's Fantasy Island. The plane through 3, 1, -2 that satisfies the given condition. And the first thing we need for number 5 is going to be number 5. It's parallel to the XY plane. All right. And I'm going to go. Oh my goodness, this is crap that I was. Oh, well, okay, here. Dun, 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 dun. All right, so number 5. Let's think about this for a minute. I'm going to make my little just to get an idea of this. So, in the convention of what we're doing here in this book, this is Z, right? And we're looking for the plane that passes through what? 3, 1, negative 2. Okay, well, it's gonna, let's see, 1, 2, 3. Okay, so I go to that point first, and and then I go over 1. Right, but then I go down -2. Right, so here's the XY plane. Right, here's the XY plane. Dot, 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 dot. Yeah. Let's see. So I've got to have this point, right? It must be this plane, here, which is the plane. You can just look at it. Z equals -2. All right, so let's do number 6. Number parallel to the XZ plane. All right, so here's the XZ plane. So wouldn't it be the plane? Well, okay. I'm going to make sure that this is this is the plane going up here, XZ plane. So if it's parallel to the XZ plane, right, I would go 3, and then my Y would be 1, and Z -2, right? So that should be the plane Y equals 1. The Y equals 1 plane. All right. With me? All right. 6, number 7. Perpendicular to the y-axis. All right, so here's the y-axis, right? And the plane, again, isn't that going to be y equals 1? Here's the y-axis, right? So it passes through this point here, 1. So shouldn't that be y equals 1? Yes, it should. All right, and 8. Perpendicular to the z-axis. Okay, so here's the z-axis. It's going to be z equals -2, the perpendicular to the z-axis. Is that not? parallel to the YZ plane. Nine. Parallel to the YZ plane. Well, that's got to be the plane x equals 3, doesn't it? This one. Perpendicular to the x-axis. All right, so here's the x-axis going along here. It passes through x equals 3. All right, it also must be x equals 3. All right, in exercises 5 to 10. No. In exercises 11, excuse me. Let me just 11 through 18. What? Find an equation for the sphere that satisfies the given condition. Find and centered at 0 to -1 with radius 3. So let's do 11. Centered at 0 to -1. 0 to -1. R equals 3. Radius 3. All right, so we just a quick reminder, we got x minus a squared plus y minus b squared plus z minus c squared is equal to r squared. So all I got to do is go x minus 0 squared plus y minus 2 squared plus z plus 1 squared equals 9, right? This here, 11, 12, so 12, centered at 1, 0, -2, 1, 0, -2 with r equals 4. Okay, so we would have x minus 1 squared plus y minus 0 squared plus z plus 2 squared equals 16. Let's see. 13. What are we doing on time here? We're doing pretty good. It's gonna, yeah, to me, it's gonna be interesting to see how long does it really take to go. Because usually, when you're at least when I was in undergrad school, they never assigned like the even problems. They only assigned the odd problems. So you did half of what was there, and generally we didn't do anything challenging. Uh, Teacher would get complaints from the students. All right, so let's see. Centered at 2, 4, negative 4. Centered 2, 4, minus 4. And passes through the origin. Zero comma 0 comma 0. That's thought provoking. So the the question is like, what's the radius, right? So I've got x minus 2 squared plus y minus 4 squared plus z plus 4 squared equals r squared. Now, my first instinct, and I don't know if it's right or not, is something. I'm wondering what happens if it doesn't really tell. Let's see. If I put in, for example, if I put in 2 comma 4 comma negative 4, right? That's gonna give me 0. But I'm looking for r the radius. So what I need is the distance from this point I need D AB, right, where A is 2, 4, -4. And B is 0, 0, 0. Right? And I'm going to get that by going D A B equals the root of all right. Looking good. Oh, what's that? Four plus 16 plus 16, which is equal to the root of 36, which is equal to 6. So therefore, R is equal to 6. And my formula then is going to be x minus 2 squared plus y minus 4 squared plus z plus 4 squared equals 36. Oh! All right, so for the next problem, let's do number 14. Centered at origin passes through what? 1, -2, 2. So I need DAB, where A is equal to 0, 0, 0, and b is equal to 1, -2, 2. Right. And that's going to be the root of 1 squared, 1 minus 0 squared, 4, -2 minus 0 squared is 4 plus 2 minus 0 squared, 4. So my distance is going to be 9 root 9. So that's going to be equal to 3. So I've got my formula is then going to be x minus 1 squared plus x plus 2 squared plus z minus 2 squared is equal to 9. All right. Is that right? I'm looking at the... Oh, no, it passes through. Look, this is where I made the mistake. I'm centering it at this point. It should just be centered at the origin. So it should have been x squared plus y squared plus z squared equals 9. Right? And this is wrong. Because that means it would be centered at this point, and that's not what the problem is asking for at this time. No. Let's see. How am I looking here? Right. 15. The line segment joining what? 0, 4, 2. Let's put these over here. 0, 4, 2. And 6, 0, 2. Is a diameter. All right, so what it's going to be centered at the midpoint of this. So I've got 0, oh, wait, no, is that a 6? Second one. Oh, no. So that would be 6 plus 0 divided by 2. That should be 3, 0 plus 4 divided by 2. 1, 2 plus 2 is 4 divided by 2 is 2. 3, 1. So the sphere is centered at 3, 1, 2. So it's going to be x minus 3 squared plus y minus 1 squared plus z minus 3 squared is equal to the half of the distance from here to here. Half of this distance. So the distance formula then 36, 16. I'm just trying to do this in my head. Plus 16 root 30. That's going to be root 52. Is that right? And I'm suspicious because, I'm expecting it to come out not as, some nice thing. So I would have the square root of 6 minus 0 squared. That's going to be 36. And no, okay. And then, the square root of 36 plus 0 minus 4 squared plus 16 squared plus 2 minus 2 squared is 52, which is 52 is 2 times 26. I don't even think I need to do that. Let's see. I need half the radius. It's got to be half the distance. Let me see. Make sure my stuff is showing up right. Well, please try to ignore this. This is the volume of a sphere. And I've got the point 042 and the point 602. So I need the root. The distance is going to be 6 minus 0 squared plus 0 minus 4 squared plus 2 minus 2 squared. Yeah, that's right. Is equal to 36 plus 16. Yeah, I had it right. It's 2 root 13. Is the distance, and we need to divide it by 2 and then square it. So finally, my formula is going to be, what did I have on the other page? X minus 3, 1 minus 1, z minus 3. That should be it. I mean 2. 2. All right. All right, let's see where we're at. I think we're done. Okay, so yeah, we're right on the hour. So I'm going to go ahead and stop, and we're going to pick up again tomorrow. Inshallah, we will. At the same bat time, same bat channel. 5 o'clock EST. So we made it to problem 15. All right. So see you next time.